Welcome to my channel Code with Fernando. We are going to start a new series. In this one, we are going to talk about Docker and how to make container Java apps using Dockerfile, Buildpacks, and Google Jeep. So we'll go step by step through Docker basics, image creation, and Docker Compose. I think I'm going to make about 5 videos out of this. The first one will be Docker and containerization basics. Then we go for create a Docker image with Dockerfile. Then create a Docker image with Buildpacks, and finally with Google GIB. At the end of this video, we are going to talk about Docker Compose, and we're going to make a demonstration of that. So let's begin with Docker containerization basics. So it's really important to understand what is this technology. It is a technology that helps package an application along with everything it needs to run, such as libraries, dependencies, and configurations. This package is called container. Okay, each container runs independently and ensures the application behaves the same way across different environments, whether on a developer's laptop, a server, or it may be in the cloud. Unlike virtual machines, containers share the host operating system, making them lightweight, fast, and efficient. This improves software deployment by reducing compatibility issues and making scaling easier. For example, if a developer creates an app inside a container, it can be moved to another machine or cloud platform without any modification, making sure consistency and reliability. So what is a container? It's a lightweight, standalone unit that packages an application along with everything it needs to run, such as code, libraries, dependencies, and configurations. It makes sure the application runs consistently across different environments. Containers are isolated from each other and the host system, but share the same operating system kernel. This makes them faster and more efficient than virtual machines, which require a full operating system for each instance. Some key characteristics of containers: portability, isolation, efficiency, and scalability. For example, a developer can create a web app inside a container and deploy it on different servers without worrying about compatibility issues. So what is Docker? Docker is an open source platform that makes it easy to build, package, and run applications inside containers. It automates the process of creating, deploying, and managing container applications. With Docker, developers can package an application and its dependencies into a single unit, which is called container, that runs consistently across different environments, whether on a local machine, a server, or in the cloud. Key benefits of Docker: portability, build once, run anywhere, without compatibility issues. Efficiency, uses fewer resources compared to virtual machines. Scalability, easily deploy and manage multiple containers. Faster deployment, applications start quickly without complex setup. For example, a developer can use Docker to package a web application on their laptop and then deploy the same container on a cloud server without any modification. What can I use Docker for? Docker is used for developing, shipping, and running applications in a fast, efficient, and scalable way. It helps developers and teams simplify software deployment across different environments. Some common use cases: application development testing, microservices architecture, CI/CD pipelines. Let's continue understanding Docker architecture. So, Docker daemon. Docker daemon is a background service that manages Docker on a system. It listens for commands from the Docker client. So we have a Docker client and we have Docker daemon, and handles container operations. What does a Docker daemon do? Manage containers. It starts, stops, and removes containers, handles images, pulls images from registries and builds new ones, manages network and storage, setups, network and handles persistent data, communicates with the Docker client, executes commands like Docker run or Docker build. How it works: the Docker client sends a request, the Docker daemon pulls the image, it creates and stuffs a container from the image, the container runs in an isolated environment and hosts the machine. Docker client. It is the main way users interact with Docker. It is a command line tool that sends requests to the Docker daemon, which then executes the requested actions. What does the Docker client do? It sends commands like Docker run, Docker build, or Docker stop, communicates with the Docker daemon, which manages containers, can run on the same machine as the daemon or remotely control a Docker server. How it works: the user enters a command, The Docker client sends the request to the Docker daemon. The daemon pulls the image and starts a container. The user gets the output in the terminal. Docker Desktop. It's an easy to use application that allows developers to run Docker on maybe Windows, Mac OS, or Linux with a simple interface. It includes everything we needed to build, test, and manage containers locally. What's included in Docker's desktop? Docker image, runs and manage containers, Docker CLI, Docker Compose, Kubernetes, graphical user interface. So, is there any reason to use a Docker desktop? Sure, there are many. It's easy to install and set up, runs containers locally for developing and testing. It works perfectly on Windows, Mac OS without needing a separate Linux virtual machine. It provides a graphical user interface to monitor containers visually. So it's really interesting, and you have the option to go to the web page and get the Docker desktop application. Docker objects. In Docker, everything's an object. These objects are building blocks of containerized application. I'm gonna mention some main Docker objects. Images, a blueprint for containers. It contains everything needed to run an application. For example, code, dependencies, libraries, configuration. Then we have containers, a running instance of an image. So we need, in order to create a container, we need an image. They're isolated, lightweight, and can be stopped or deleted. Then we have volumes, used for persistent storage in containers. Data inside a container is lost when it stops unless stored in a volume. Networks enable communication between containers and other systems. Default networks bridge, host, and none. Docker registries, storage location for Docker images. There's one public registry, it's called Dockerfile. There's also private registries can be used for internal projects. So what is a Docker image? It's a lightweight standalone package. It contains everything needed to run an application, including code, runtime, libraries, dependencies, and configuration files. So images serve as a blueprints for containers. When you run a container, it's created from image. Key features of Docker images. They're read-only, layer structure, reusable, and portable. Now, finally, Docker container. It's a lightweight standalone environment that runs an application. It's created from a Docker image and includes everything needed to execute the application. Some key features of Docker containers. They're isolated, portable, lightweight, and ephemeral. Can be stopped, or removed easily. What is Docker Hub? It's a cloud-based registry where Docker images are stored, shared, and managed. It is default public registry used by Docker. Key features of Docker Hub: stored images, image sharing, official images, automatic builds. Pub mapping in Docker. So what is pub mapping? It's a process of connecting a port on the host machine to a port inside a Docker container. This is really important, really. Why is it needed? Containers run isolated from the host system. By default, applications inside a container cannot be accessed from outside. Pub mapping allows external traffic to reach containerized application. Simple example, we have our Spring Boot application inside a Docker container. The application listens on port 8080 inside the container. Without pub mapping, it cannot be accessed from the host system. So, by mapping the host 8080 and the container 8080, we make the app accessible.